Hello everyone, how is it going? My name is Ahmed Inaya, and in this series of videos I will talk about some network fundamentals that everyone should know before working or studying networking. In this video or in this part, I'll talk about decimal, binary, and hexadecimal numeral systems. These systems are important for anyone who wants to understand how computers communicate and how they find the location of each other. So in this video we'll talk about three different numeral systems that are used in computer networks. We'll start by talking about decimal or base 10, then binary, base 2, and we'll talk also about hexadecimal, which is base 16. In the coming few slides, I will discuss these systems in more details. So let's start by talking about decimal numbers, which are the common numbers we use in our daily life. Decimal means 10, and this is the numbering system that we teach to our kids in school and we use when we sell and buy products or when doing any calculations. It is the most common numeral system in our daily lives. So why 10? What is unique about 10? I think this is mainly because we have 10 fingers, so humans found it much easier to calculate based on 10 rather than any other numbering system. But this is valid for humans. Computers don't have fingers, so it doesn't make sense for computers to use the same numbering systems as humans. But let's try to understand this system more, because whatever applies into this system can be used also to understand other systems. So the numbers of decimal system are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which are the numbers that we use in our daily life. So let's take this number for example. As we can see here, these numbers 3, 6, 7 have different values based on the location of these numbers. So this 3 for example has different value than 6 and have different value than 7. 7 is ones, so this means this 7 is only ones, only 7. 6 is tens, which means this number is 60 actually, and this 3 is 300, so this number is hundreds. And we can keep going on for thousands, tens of thousands, hundreds of thousands, millions. So let's try to classify these numbers into hundreds, tens, and ones. So if you want to get the value of any of these numbers, you multiply it by the unit of this location. So the number here is multiplied by 100, the number here is multiplied by tens, and this number is multiplied by ones, which means the same number exactly. If you want to convert this into mathematical formulas, we can say the number here is multiplied by 100, the number here is multiplied by 10, and the number here is multiplied by 1. And if we use power of, we can say this number is multiplied by 10 to the power of 0, this number is multiplied by 10 to the power of 1, and this number is multiplied by 10 to the power 2. So one way or another, we can say that this number has the location of 0, this number has the location of 1, this number has the location of 2. So based on number location, we decide the value of this number by multiplying this number by 10 to the power of the same location of this digit. And this is the way numbering system can be represented in mathematical formula. If this is clear to you, let's move on and discuss another numbering system. So after decimal numbers, let's start by talking about binary numbers. Binary numbers are the basic numbers used by computers, and this is mainly because computers store data and exchange data as on or off signals, or 0 or 1. To simplify it, let's represent this by two bulbs or two lamps. One of them is off, means 0, and the other one is on, which means 1. So when computers want to send information between themselves, they use these bulbs to exchange signals. If the bulb is on, this means 1. If the bulb is off, this means 0. It is much more complex than this, but let's use this example to simplify things. Similar to decimal numbers, the value of the digit depends on its location. So if the bulb is here, it has different value than the bulb which is here, and the exact value depends on the exact location of this bulb compared to the whole number. And if we apply the same formula that we use in decimal numbers, it is exactly the same. So the value of any number equals the number times 2 to the power of the digit location for this number. So for example, if we have 4 bulbs and these two computers want to exchange information using these bulbs, assuming we have these values, so this is 0, the bulb is off, which means 0. This bulb is on, which means 1. This one off means 0. And this one on means 1. We apply the same concept we used in decimal numbers, which says the value of this bulb equals whatever here times 2 to the power of 3, because the location of this bulb is number 3. It all starts from here by 0, 1, 2, 3. So the value of this bulb is multiplied by 2 to the power 3. The value of this bulb is multiplied by 2 to the power 2, and this one 2 to the power 1, and then 2 to the power 0. If we convert this into decimal, 2 to the power 3 is 8, 2 to the power 2 is 4, 2 to the power 1 is 2, and any number to the power 0 is 1. And if we did the math, this is equals to 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1, and this equals 5. This 5 actually is decimal, so this way we can convert any binary number into decimal. So if you see two computers exchanging information by using this arrangement of bulbs, you know that this number equals 5 decimal. So as a result, 1010 binary equals 5 decimal. If this is clear to you, we can move to the next numbering system, which is hexadecimal numbers. Hexadecimal means 16. So when we say hexadecimal number, this means this number is to the base 16. And similar to decimal and binary, hexadecimal numbers are from 0 to F or from 0 to 15 decimal. So how this works? What is F? Let's look into the details of these numbers. The numbers from 0 to 9 are similar to decimal. Because we have these numbers already, they found it easier to keep these numbers the same in hexadecimal system. But how about the numbers from 10 to 15? To provide symbols for these numbers, they use the letters from A to F. So the letter A in hexadecimal equals 10 in decimal, the letter B equals 11, C 12, D 13, E 14, and F is 15. So what is the importance of hexadecimal? If computers are using bulbs or binary systems to exchange information, why do we need hexadecimal? In one way or another, hexadecimal numbers can be used to shorten binary numbers. So instead of having long binary numbers, you can have shorter hexadecimal numbers. And the good thing about hexadecimal is that every 4 digits of binary system are equivalent to 1 digit in hexadecimal, which makes mapping between binary and hexadecimal and vice versa much easier than decimal system, and we will discuss this more in the coming videos. If we apply the same system that we used in decimal and in binary, the value of any digit is equal to 16 to the power of the location of that digit. And if we apply the same concept we used in decimal and in binary, the value of any digit in hexadecimal equals 16 to the power of the location of this digit. So for example, let's assume we have this number. This is a hexadecimal number, 2ED. And if we apply the same concept we used in binary and decimal systems, considering that this is digit 0, this is digit 1, and this is digit 2, so this leads to these numbers. This value should be multiplied by 16 to the power 2. This value, which is 14, should be multiplied by 16 to the power of 1. How did we get 14? This is from this table. We know from this table that E equals 14. So E hexadecimal equals 14 decimal. So if you want to calculate the value in decimal, we should multiply this E14 by 16 to the power of 1. D equals 13, and based on its location, it should be multiplied by 16 to the power of 0. If we did the calculation in decimal, we know that 16 to the power of 2 is 256, 16 to the power of 1 is 16, and 16 to the power of 0 is 1. Actually, any number to the power of 0 equals 1. And if we did the calculation to find the decimal equivalent of this hexadecimal number, we need to multiply 2 by 256 and 14 by 16 and 13 by 1 to get this number, which is 749 decimal. So 2ED hexadecimal equals 749 decimal. So how to do conversion between these numbers? If we want to convert from decimal to binary or binary to hexadecimal, we will discuss this in the next video. But for now, you can use calculator. Any scientific calculator should have a way to convert between hexadecimal, decimal, octal, and binary. So for example, this is from Windows 10. If you use programmer interface, you can easily convert between these numbers using this calculator. In the next video, we will discuss this conversion in more details without using any calculator. If you find this video useful, please like, subscribe, and enable notification to know about our coming videos.